Hello my dear students, how are you? I hope all of you are doing very well. And I believe your studies are also going on very good. Let's continue with exercise 13.2. So in the previous video, we have seen a small introduction on cylinders, how to find out its surface areas, curved surface area, total surface area as well. Let's move on to with the exercise, that is exercise 13.2, question number 3. I've written on the question for you also, that is a metal pipe. So let's not forget this metal. A metal pipe, maybe iron. A metal pipe is 77 centimeter long. So as I told in the first video, long means length, but for a cylinder, length and height represents the same term for a cylinder, because for example, if this is the cylinder, when I place it like this, it becomes the length. But the same cylinder, if I place it like this, vertical, then what happens is that length also can be used as its height. So don't confuse with the length and height of a cylinder. Once again, in this format, it will be length. Place it vertical, it will be also considered as height. Okay. So height in bracket will be length of cylinder. We will use H, that is 77 centimeter long. The inner diameter of a cross section is 4 centimeter and the outer diameter being 4.4 centimeter. That means we have a pipe, we have actually two pipes, one inside the other. That means if we look in this form, through the area of cross section, we have two circles. That is, one is the smaller circle, inside circle, and one is the outer circle. And since it is metal, this portion is also made up of metal. It is not hollow. It is not mentioned in the question that it is hollow. This radius, of course, is not given, but for that, what is given is diameter is given. The inner diameter is given. We can find out the inner radius. I'll do it directly. The inner radius. Let's use small letter r. The inner radius will be diameter. We know the relation between radius and diameter. Radius is always equal to what? Diameter by 2. So whenever you get these questions of diameter and all, please make sure that you first get the radius by converting or by dividing it by 2. By dividing the diameter by 2. Because usually we do not need the value of diameter except for the radius. Radius is what we need. So radius will only be diameter by 2. So let's not write down too many things. Let's calculate the inner radius directly. Inner radius r will be equal to diameter. For the inner one, it is 4 centimeter. 4 centimeter upon 2. So that's going to be 2 centimeter. Similarly, outer radius. Let's denote it by capital R. That is this outer radius. Let's denote it by capital R. This smaller by small r. So the outer radius is diameter is 4.4. 4.4 by 2. So that's going to be 2.2 centimeter. Okay, now that is decided. Now the question is, find the inner curved surface area. So that's quite simple. That means if we just assume like this to be the cylinder and maybe this to be the thickness, this is the outer, this is the inner. So the inner, first we are supposed to find out the inner curved surface area and then the outer curved surface area, and also the total surface area that we will discuss. So let's continue. Let's quickly do. I'll rub this part, question part. So what will be the number 1? Inner curved surface area. So what was the formula? 2 pi r h. So that's going to be 2 into 22 by 7 into radius was 2 centimeter into height or length, that is 77 centimeters, 711. So 2 2s are 4, 88 into 11 centimeters square. So 88 into 11 short 88, 88, 8, 16, 1, 9. So that's 968 centimeter square. Okay, let's find out the outer surface area. Outer curved surface area. That's going to be 2 pi capital R H. 2 into 22 by 7 into capital R, radius 2.2 centimeter, height again 77 centimeter, again 11 times. So this will be 44 into 2.2 into 11 centimeters square. So I've done the calculation in advance so that we don't waste much time. So this value you should be getting us 1064.8 centimeter square. You can do the calculations and check for yourself. Okay, so that's the inner curved surface area, total curved surface area, not a big deal. Now the third one is the total surface area. So here only you have to think. Total surface area. Now to find out this, so what did we discuss earlier? Surface area means the area of all the surfaces that a particular object has. So of course this is not a very proper diagram figure, but like how many surfaces will our given pipe have? Well, it will have, of course, the inner curved surface area, right? The outer curved surface area. Also, see, this pipe, it is said to be of metal. That means even this portion also on the tip of the cylinder. That means this is like, if we assume it to be a bit thicker. If we assume it to be a bit thicker, then even this portion, the thicker portion, this portion will also have some surface. We have to find out even the surface area of that particular portion also. Okay, so that's going to be total surface area will be now the inner surface area, outer surface area plus the surface area of the thickness at the area of cross section, this thickness, this portion. Okay, so let's find out the area of this portion. So here we will use the area of concentric circles. That is, how to find out the area of this particular portion in your previous chapters, lower classes also we have done. It's going to be area of the outer circle minus area of the inner circle. So from the outer circle, if you remove the inner circle, what are you left with? The shaded portion, isn't it? So that's how we're going to find out. So let's write down area of the bases. Let's say area of surface, area of the base. That's going to be, so how many bases will we have? This is one side, isn't it? One side. So it's going to be what? Bigger circle minus smaller circle. We have but two circles, even on this side also. One here, one here. So that's going to be two bases, 2 pi r square minus 2 pi r square. That is area of the bigger circle minus area of the smaller circle. Area of the bigger circle minus area of the smaller circle. But why are we doing two times? Because we don't have only one circle. Because for a pipe, this side as well as this side. So we have two circles each. This side, it's on the other end of the pipe also, this one. So that's why area of the bigger circle, how many? Two big circles. Minus area of the smaller circle. Again, how many? Two smaller circles. One here, one here. Big circle also, one here, if the thickness is this much, and the other on that side. That's why we take two to each. Okay? That's one mistake which we should avoid, I mean. So let's simplify this. So that will be 2 into 22 by 7 into a square minus b square. I will use this formula. That will be easier for me, for us. 44 by 7 into r was 2.2 plus 2. 2.2 minus 2. 44 by 7 into, this will be 4.2 into 0.2. Because 2.2 minus 0 minus 2. 2 means 2.0. That's going to be 0.2. Now 7, 6 are 42, but it's 4.2, so that's going to be 0.6. So that's going to be 44 into 6 2s are 12, 1, 1. We have two decimals, so 1, 2. Two decimals, so 0.12. Of course, unit, let's not forget to write centimeter square. Okay. So, let's calculate this value. So that's 44. Ignore the decimal. In the last, we can put 2 2s are 8, 2 2s are 8. 44, 8, 12, 1 left, 5. So that's 5, 2, 8. We have two decimals, so 5.28 centimeters square. This is just the area of the base, the circular portion, the thickness portion. Now let's find out the total. So total surface area, that's going to be inner curved surface area plus outer curved surface area plus area of the base, area of the bases, the two bases. So what was our inner curved surface area? Our inner curved surface area was 968. What was the unit? Meter or centimeter? Okay, centimeter square plus the outer curved surface area 1064.8 centimeter square plus area of the two bases, the shaded portion, that's 5.28 centimeter square. Let's add this. 968 1064.8, so 0.0, 5.28. So we just have to add, so we can just put on the decimal. 8, 8, 9, 10, 1 left, 8, 12, 13, 18, 1 left, 12, 13, 1 left, 9 plus 1, 10, 1 left, 2. So that's going to be 2038.08 centimeter square. So this will be the total area of the surfaces that our metallic pipe will have. Okay, so we have to do this very steadily and use our common sense, especially use our senses, especially to find out the area. Are you done? Okay, I'm going to wrap this off next. Quickly, let's move to the next question. What is our next question there? I will just read the question. Please try to follow. I hope you have your textbook. Question number 4. The diameter of a roller is 84 centimeter. Roller, I hope all of us know, especially you may have seen it in football grounds or cricket grounds where we use a roller, something like this, where we use the roller to level the ground, right? The diameter of a roller is 84 centimeter. So what will the radius quickly? Just what I say, radius of roller. Diameter by 2, so that's 42 centimeter. And its length, again, the length. So if I put it vertical, it's going to be the height. So length, or in other words, height, h, is given to be 120 centimeter. 120 centimeter. It says it takes 500 complete revolutions. Complete revolution. That means if this is 1, so let's say if we just put a mark here, then 1 complete revolution, maybe I put a mark on this part. So 1 complete revolution means, for example, like this. Okay, if this is my mark, so 1 complete revolution, that means from here, if I start, 1 complete revolution maybe, okay, let's start from here. Okay, this is my starting point. So this is the roller. So 1 complete revolution means I put my mark here. So let it complete 1 complete revolution till it comes back to its original position like this. So it has come back to its original position. So this is my 1 complete revolution. That means in 1 complete revolution, what happens is this much area has been covered by the roller. Something like this. 1 complete revolution. Again, if I start from here, 1 complete revolution, it has come back to my original point here. So this is the area that it is rolling, isn't it? That it is leveling. Now it says this is 1 complete revolution. It says that it takes 500 complete revolutions to move once, only once, to move once over a level playground. That means That's why when we level a playground, you must have seen, when we level a playground, you can see that the tire is revolving. That means it is completing a lot of revolutions. So they're saying that just to level the playground one time, it takes 500 revolutions. That's the concept given to us, 500 revolutions. Now, question is, find the area of the playground in meters square. Forget about the unit, we'll discuss that later on. Find out the area of the playground in meter. That means this one, 500 times, if I add same quantity, if I, with that I will be able to get an idea of the total area of the playground. That means if I can find out the area covered in one revolution, all I have to do is, this is the area covered in one revolution. So if I can find out the area, suppose say the area covered in one revolution was 4 meters square, for example. So it takes 500 revolutions to level the ground once. So all I have to do is multiply it by 500. So it's going to be 2000 meter square. That means the area of the ground, let's say this is the board, this is the playground. So that means multiplied by 500, the full board will be leveled one time. So the total, that means the total area of the board is 2000 meters square. So that's what we are going to try to do. That means what we will do is we will try to find out the area covered by the roller in one revolution. So what is the area covered by the roller in one revolution? It is the curved surface area of the circular portion. It is the what? Curved surface area of the circular portion. Because this portion, when we roll, this portion is not leveling the ground, isn't it? Only the curved surface is leveling the ground. We know that a roller is made up of metal. This portion also exists, this portion also exists. But when it's completing one revolution, what happens is only the curved surface area is leveling the ground, not the circular portion. So area covered by roller in one revolution, that will be what? Curved surface area of, I'll write it in short, curved surface area of the roller. So what is the formula for curved surface area of the roller? 2 pi r h. So that's going to be 2 into 22 by 7 into radius 42 centimeter into height 120 centimeters. So cancel it by 6. So 44 into 0, 6 to 12, 1 left, 720 centimeter square. So this is the area covered by the roller in one revolution. We have to find out the total area of the field. Now, area, okay, area, we can do like this. Total area of the field or playground will be equal to what? Area covered in 500 revolutions. That is what the question gives us, that in 500 revolutions we can complete the leveling the ground. So this is going to be 500 into, because this is the area covered in one revolution. So in 500 multiplied by 500, multiplied by 500, 44 into 720 centimeters square. But the question tells you to find out the area covered in terms of how, what? Meters square, not in terms of centimeters. So I will convert this to meters square. So 44 into 720. We know that 100 centimeter is equal to what? 1 meter. That means 1 centimeter is equal to 1 upon 100 meter. But how many units of centimeter do we have here? 2, square, centimeter square. So that means not only once, not only by 100, but we have to do it 2 times to convert it into meter square, because it is meter square. So that means we have 2 meters here, like meter into meter. So from centimeter square, if you have to convert to meter, centimeter to meter, centimeter to meter. So it's 1 by 100 into 1 by 100, because smaller to bigger we divide, isn't it? So 1 by 100, 1 by 100. So we have to multiply, divide by 100 by 2 times 100 and 100, because it is meter square, because it is centimeter square. Centimeter square to meter square for 1 centimeter, and for 1 centimeter 2 times. Okay. Let's cancel this if we can. 1 0 gone. Here also 1 0 gone. Let's multiply. Quickly, let us multiply and find out. So this is going to be 44 into 5. 5 4s are 20. 2 left, 5 are 20. 21, 22. Into 72. 0, 4, 4. 0, 7 is a 14. 1 less 1 is a 14. 15. 0, 4, 8, 5, 1. So that's 15840 upon 10 meters square. 1010 cancels again. So 1584 meters square is the total area of the playground. Okay, so that is what the question is all about. Alright, so alright then, so let us try. Okay, we will just stop here because it is already gone 20 minutes off. So we were able to do only 2 big questions. So in the next video we will see again how many questions we can cover up. Alright, so I don't want to be making the video very long for all of you so that it doesn't turn out to be very boring. So alright then, so till then, see you in the next video with the other set of questions, maybe 2-3 questions we will try to solve. So please, I hope you're studying well, stay safe, stay at home, and then of course do study well. And then definitely if you have liked this video, please don't forget to like, share, and please subscribe also. Okay, alright then, till then, take care, bye bye, thank you.